Students, this question was asked in NEET 2012 from chapter 5 of class 11, that is from the chapter of work, energy and power. Two spheres A and B of mass m1 and m2 collide. A is initially at rest and B is moving with velocity v along x-axis. After collision, v has a velocity v by 2 perpendicular to the original direction. The mass A moves after collision in the direction we have to find out, students. There are two spheres A and B. Okay, suppose this is A and suppose this is B. Its mass is m1 and its mass is m2. And A is initially at rest. Okay, and B has a velocity v by A is initially at rest and B is moving with velocity v along x-axis. B is moving with velocity v along the x-axis. Suppose this is the x-axis and this b is moving with velocity v. Okay, student, this one is 0. Velocity is 0. Initial velocity or v1 is 0. After collision, b has a velocity v by 2 perpendicular to the original direction. The initial direction was along the x-axis. So after collision, it will move. B will move in which direction? B will move in this direction, the y direction, y-axis. Okay, and suppose A moves in this direction, students. Suppose A moves making an angle theta with x-axis. Let us this be theta, this be the velocity of A after collision. Let us denote this by v prime. Then, student, or we may denote this by capital V. Let us denote. So, students, we will apply the principle of conservation of linear momentum. There are two situations, before the collision and after the collision, and we will compare their linear momentum along the x-axis and the y-axis, so that we can get the value of theta. Let us first consider the first situation. m1, then m1 u1 plus m2 v2. Okay, student, this is equal to m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. This will be the equation. This is the linear momentum before the collision, and this will be the linear momentum after the collision. Or we may write, students, in place of 1, we may write the mass of A into the initial speed of A, the mass of B and initial speed of B, the mass of A, the final speed of A, mass of B and final speed of B. This will be better, students. So, what is the mass of A? It is given m1. Okay, student, it is given m1. So, we may write here m1, and A is initially at rest, so UA is 0, or this term will be 0. Then, the B was moving with a velocity v. So, initial velocity of B is v. So, we may write here v and along the x-axis. Okay, student? And its mass is m2. So, mass of B is m2. So, we may write m2. Okay, student? And after collision, okay, this is along the x-axis. Okay? And what is the components of the linear momenta of A and B along the x-axis? This is the x-axis, this is the y-axis. Let us see. This V has, suppose this is the x component, students. This will be how much? This will be V cos theta, and its component, y component, will be this one will be equal to V sin capital V. We have written capital V sin theta. Okay, student. So, along the x-axis, this will be mass of the B moves along the y direction, so it has no projection along the x direction. This velocity of the B has no projection, so the velocity of B along x-axis is 0. So student, this will be 0. B along x-axis will be 0. So this term will be 0. And what is mass of A? Mass of A is m1 given, and velocity of A along the x-axis will be equal to student V cos theta. So this is m1 V cos theta. So m2 V is equal to m1 V cos theta. We may write here m1 m2 V, or we may write cos theta. Cos theta, what will be cos theta, student? Cos theta will be equal to m2 V by m1 V. We may write here cos theta is equal to m2 V by m1 capital V. Okay, students? Then in the y direction, if we consider the motion or the components of the linear momentum along the y direction, what will be the equation, student? Then you see, what is the component of linear momentum of particle B along the direction, that is V by 2. This tells after collision B has a velocity V by 2. So this B is moving with velocity V by 2. Okay, student, and it has mass m2. So m2 and V by 2. This is V by 2. And what will be the final momentum in the y direction, student, of this body A? This is, we have find out, this is V sin theta, the velocity component velocity of A along the y direction is V sin theta. So it has mass m, so m1 V sin theta is equal to, this is the components, the sum of the components of linear momenta of body A and body B after the collision. And what is before the collision, student? Before the collision, A is initially at rest. So students, the velocity of body A before the collision was how much? V is 0. So students, the Vx will be 0 and Vy will be 0, student. So along the y-axis, obviously m1 into the velocity of the body A along the y-axis is 0 because its velocity V is 0, so its Vx is 0 and Vy is 0. And let us write the linear momentum m2 V2. And what is V2? V2, the body was initially, B was moving with velocity V along the x-axis. The body B was moving along x-axis. So the entire velocity is along the x-axis and y-axis is perpendicular to x-axis. So student, its component along y-axis is 0 because the theta between x-axis and y-axis is pi by 2. So student, cos pi by 2 is 0. So V2y or the y component of velocity of the body B is 0. This one V2B is student 0. So the initial momenta of both the body A and B along the y-axis, both the terms are 0. So student, m2 V by 2 plus m1 V sin theta is equal to 0. So from here we may write this m2 V by 2 is equal to minus m1 V sin theta, student, and from this we can find out the value of sin theta. What is sin theta? Sin theta becomes m2 V by 2 m1 V. This m1 V will go but there is a minus sign, student, so we will write here minus. And here cos theta is given m2v by m1v, sin theta is minus m2v by twice m1v. So what will be tan theta, student? Tan theta is sin theta by cos theta. Let us write here tan theta. Tan theta will be equal to, you see, minus m2v by twice m1v by m2v by m1v. This m2v cancel, m1v cancel. Simply this will be minus 1 by 2. Okay, students. So what will be theta? Theta will be tan inverse minus 1 by 2. Okay, student. And this theta is along, we have drawn the angle along from the x-axis. So this is the option, that theta is equal to tan inverse minus 1 by 2 to the x-axis. The angle at which body A will move after collision is tan inverse minus half along the x-axis. So option D is correct, students.